Hello, students. Welcome to Engineering Geology and Hydrology. Today we are going to learn about geological hazards of landslides. Landslides can be very destructive. It usually occurs during the rainy season. For example, on November 16, 2015, a landslide occurred in Lishui, Zhejiang Province. 26 people were killed. 11 people are missing. ABA, Sichuan Province, 2017. Occurs a high-altitude landslide. It blocked the river for 2 kilometers. A landslide occurred in Shuichang, Guizhou Province, in 2019. 1,600 people were affected. 43 people were killed. The direct economic loss was 190 million yuan. Landslides are a great hazard to the construction and operation of projects. It's a killer hidden in our engineering construction. Let's take a look at the concept of landslides. A landslide is a mass of rock and soil on a slope. Under the influence of gravity, slide along a certain sliding surface, or sliding zone as a whole. Such a geological phenomenon. We call it a landslide. The basic elements of a slope include landslide mass, sliding surface, slide bed, slip cliff, landslide perimeter, landslide step, slip tongue, landslide fissure, drum mound and axis. Classification of landslide. It can be composed of matter, cohesive soil landslide, loess landslip, rubble soil landslide, bedrock slide. We can also follow the scale of the landslide. Divide into small-scale landslide, medium-scale landslide, large-scale landslide. We can also classify them based on mechanical properties. Divided into traction landslide and push landslides. Landslide conditions. The formation of landslides is generally related to the following 7 factors. It is mainly lithologic tectonic landform, water, weather, earthquake, and human factors. Lithology. Landslides occur mainly in loose deposits. Bedrock landslides are relatively rare. Landslides of loose deposits is mostly about clay. Sliding surface. The sliding surface mainly occurs in clay interlayer. The relationship between landslide and structure. There are 2 main aspects. One is the relationship with weak structural planes, whether loose deposits or accumulations. Sliding surfaces often occur on slopes along the slope. Joint surface, unconformity, contact surface, fault zone, and schistological foliation inside. Second, the composition characteristics of the upper permeable layer and the lower impervious layer are related. 3. Landform. The relationship between landslides and landforms is primarily reflected through the slope gradient of free faces and the erosion at the toe of slopes. Of rivers and valleys. Cutting of the surface. First, it creates an air front for the landslide. Areas where a river scours the base of a slope are also prone to landslides. Water is an important condition for landslide. The vast majority of landslides occur along weak surfaces of groundwater, filled rock masses. When water seeps into the pores of the rock mass, aquifers are formed in cracks. It can reduce the cohesion value of rock and soil mass, even softens. Swell airslake reduce shear strength. Reduce the resistance to sliding. At the same time, water fills the pores in the soil, increasing the volume weight of water, thus increasing a sliding force of rock and soil. According to the statistics, more than 90% of landslides are linked to rainfall. Therefore, there is a folk saying that heavy rain induced large-scale landslides, and no rain induced large-scale landslides. 5. Climates. Climate, mainly determined by rainfall and temperature, significantly affects landslides. In particular, rainfall has the most significant impact. Rainfall can increase the weight of the slope, and rain can also play a role in lubrication. In addition, Landslides are also related to the action of freezing and thawing. Landslides are more likely to occur during the freeze-thaw season. 6. Earthquakes. Earthquakes can pass through the structure of rock and soil bodies that loosen slopes, cause fracture surface and cause weak surface, dislocation, and other ways. Reduces slope stability. The cumulative effect of repeated action. It may cause instability of the slope. In addition, seismic forces were suddenly applied, also damage the slope, create a trigger effect. 7. Human factors. Artificial cutting has steepened the slope. Big blasting method of construction. The load action of engineering structures on slopes. Artificial water supply. Building leakage. There are no drains in the revetment. Or poor drainage design. It's all human factors that trigger the slide. Possibility of occurrence. The factors affecting slope stability are diverse and complex. For a specific landslide, it is necessary to analyze in detail which factors play the main role, plays leading role, which factors play a secondary role. Through this analysis, it can provide an important basis for us to take appropriate prevention and control measures. Provide important evidence. Method of field landslide identification. After the landslide, it creates a series of variations, provides us with signs to identify landslides in the fields. These signs mainly include homology of double furrow, drunken forest, saber tree, and stratigraphic structure signs of hydrogeology. The first is the homology of double sulcus, rock mass on a slope. While sliding, gullies often form on either side of the slope. The phenomenon of homology of double sulcus appeared. 2. Drunken forest and saber tree. When the soil on the slope slides down, trees on the surface, there's a lot of twisting and turning, like a drunk, or looks like a saber. A tree of this shape is a sign of a landslide. 3. A sign of stratigraphic structure. The area where the landslide occurred, the integrity of the strata, is often destroyed by sliding. There is disturbance, loosening, discontinuity. There is a missing or overlapping layer. The elevation of the horizon has a rise and fall. These kind of special change, the obvious change of rock formation, and structural discontinuity are the signs of landslide. For hydrogeological indicators, a landslide is when it slides. Aquifers often cause landslides in areas. The original condition is destroyed. Make the slope form a separate water body. The hydrogeology has become particularly complex. There's no pattern. If the diving position is irregular, no definite direction, there are rows of springs overflowing below the slope. These are all signs that can identify a landslide. The above 4 signs are the products of landslide movement. There is an inseparable interconnection between them. So, in the investigate practice, we should take a comprehensive look at these signs. Verify the analysis with each other. To accurately judge landslide control measures, it is mainly divided into drainage, retaining, reduction, reinforcement, specifically divided into drainage engineering, retaining engineering, weight reduction engineering, and reinforcement engineering. Drainage refers to the removal of surface water and drain groundwater. Increases slip resistance. It could be on top of the slope and on both sides of the cut ditch. Arrange a tree-shaped drain on the slope, keeping surface water out, or it seeps into the slider. Foreground water. We can also use blind-fed ditches, blind holes to clear and drain. Support refers to a building on which a support is built. Improve the mechanical equilibrium condition of landslide. Increase one of the resistance of the sliding body. We're usually on the lower side of the slope. Construction of supporting structures, like retaining walls, like anti-slide piles. Landslide near riverbank, to prevent the river from sliding below, washing and eroding, often by building a variety of protective embankments, or a protection against erosion, like through the stone cage, to relieve the river of a wash beneath the landslide. Subtraction refers to the part that slides above the slope. Educe a sliding force by losing weight. Fixation means keeping the sliding body in place, or cemented on a sliding bed. Increase a slip resistance. If it's a monoclinal rock slide, we can anchor through the anchor rod. We can make all kinds of skeletons. Slope protection combined with grass planting. In this lesson, we mainly learn landslide concept. A landslide is a mass of rock and soil on a slope, affected by natural factors such as rainfall. Under the influence of gravity, slide along a certain sliding surface. Overall downward movement of natural phenomena. The basic elements of a landslide include landslide mass, sliding surface, slide bed, slip cliff, landslide perimeter, landslide step, slip tongue, landslide fissure, drum mound and axis. The formation conditions of landslide mainly include landform, formation lithology, geological structure and hydrogeological conditions. Landslides can be classified according to material composition. Can be divided according to the scale of the landslide. It can also be divided according to mechanical properties. Field identification of landslides, mainly based on dual gullies with common origin. Drunken forest, saber tree, stratigraphic structure mark, hydrogeological indicator. To identify landslide. Landslide control measures mainly include drainage, retaining, reduction, reinforcement.